You know how many options there are, right?
10 choose 6 times 10 choose 5.
10 choose 5 times.
Let's do the 5 first, and we'll do it add it up. So what about 5?
10 choose 5 times
10 choose 5, that gives you the black.
5.
5 choose 1 gives you the red, that gives you 6. And you multiply. Because you're talking about the same 6 balls here. Okay, you're picking 6 balls here. 5 are black, 1 are red.
Right.
Here you're picking 6 balls, and all are black. Okay, so do you add these or multiply these? And you add because these are 6 balls, that 5 are black, 1 are red. These are 6 that are all black. So you're counting different things.
Gotcha.
And then divide by
15 choose 6.
15. Questions there? Okay, induction. So the probability is kind of a toss-up. I haven't even made the test. I don't know what's on yet. The induction, this will be the same except this will change. So the one that everyone should get 100% right is P of K. You just change your n's to k's. And you don't say 10K equals 5K times K plus 1. You do the entire thing. You write it out verbatim. Exactly like that. Just change your n's to k's. Don't leave anything out. And you'll get credit for that one. Okay. The next one's probably P of K plus 1. That's where you just change your n's to K plus 1s. So 10 plus 20 plus 10. That changes to K plus 1. Make sure you put parenthesis there?
Do we not leave 10K there? I thought it was 10K plus 10K.
Yeah. Well, see, it turns out that P of K plus 1 is 10 times K plus 1. So the number right after 20 would be 30. The number after that would be 40. The number before 10K plus 1 would be 10K.
Oh, I thought we had to write it as well.
Yeah, you'll have to eventually. You can go ahead and write it there if you want. But I won't take off. It's not there. Okay, and this side would be 5, and n we're going to be K plus 1. And then n plus 2, if you plug in K plus 1, that's going to be K plus 1. Any questions there? Okay, so B and C, you should be able to get. You can sit down and write a program to do that for you. Plug those values in. Okay, the basis step is plug in n equals 1. So if you plug in n equals 1, what's this side going to be?
10.
If you plug in a 1 there, that's a 10. So it's 10 plus 20 plus 30 plus plus 10, so that means you just stop at 10. We've had that conversation a couple times. And on this side, if you plug in 1, it's 5 times 1 plus 1, which is true.
Can you give us an example of something that wouldn't make it be 10, like if it was 20? If it was 2, for example?
Yeah, if n was 2, it would be 10 plus 20.
Okay, that's perfect.
Okay, and then show P of K implies P of K plus 1. Usually what I've done in the past, this is usually 7 or 8 points, because that's the hard part. But even without doing that, you get almost half credit for the problem without doing a proof. So to do that, you look at the left-hand side of this and the left-hand side of that, and the difference is 10K. You add that to both sides. Or-
10K plus one?
10K
Yeah,
plus
sorry. 10K plus 1. He's already got 10K.
So,
And you can, from this, you can factor out a 5K plus 1. And if you do that, here you're left with K. And here you're left with 2. So on this one, when you do that, you're actually done.
Or you can spoil everything out. Or you can spoil
Pull everything out, yeah, that's it. Any questions there?
I always get lost.
Yeah, I know.
He just did some work, so then they became equal.
Yeah. I can do another one after I go through this. At this point, with induction, yeah. This, from here to here, involves a bunch of algebra skills, which I can't teach you. I mean, see what you guys are doing. But I can do a couple examples, and I'll go through that and show you.
put that exact one on there, I got it down.
It's not going to be that one, but let me show you something that I did. If you take 1 plus 2 plus n equals n times n plus 1 over 2, which is the very first one we looked at, and you multiply by 10, you get 10 plus 20 plus 10n equals 5 times n plus 1. So this is the exact same problem you've done 3 times now. I just multiplied everything by a number. Okay. Proofs. This one happens to be k is even and k squared is even. I think that's why I gave a couple tests, because these could be rational, irrational, even, odd. Also, we talked about contrapositive, proof by contrapositive, which if there is a proof by contrapositive, I'd say prove this by contrapositive. So the proof of this, like k be even, that implies k equals 2n, where n is an integer. That implies k squared is 4n squared, where n is an integer. And this is equal to 2 times 2n squared, which is even. Okay, let k be 2n, you square it, it's multiple 2. K is multiple 2, you square it, you get multiple 2. Yeah. Well, again, with the proofs, do what you can, right? So let k be even, so you know what you're going to do. And then what would the very last line be if you're trying to figure out where you're going? Hence what?
Hence k squared.
Hence k squared is even, so even if you don't know how to do the proof, you can write the model of the proof, right? You know exactly what you got to do. You get some points there, right? Any point here and point there helps. And again, I could have even, odd. You know, an odd plus an even is what? You take an odd number and add an even number, what do you get?
Odd.
Odd.